Good morning. Let's start with today's Google Classroom. So, in paper physical chemistry, paper number 8, we have already started the chapter that is a thermodynamic first. Today's topic are, so this is a topic that is the first law of thermodynamics. So, in this Google Classroom, we see what is the first law of thermodynamics and what is the statement of that is the first law of thermodynamics. So before to start with today's Google Classroom, we have to just introduce what is meant by the thermodynamics. So let's see what is meant by the thermodynamics. That is, thermodynamic is a branch of physics that deals with heat and temperature, their relation to the energy, work, radiation, and the properties of the matter. The behavior of these quantities is governed by the four laws: thermodynamic first law, second law, third law, and fourth law. So today's Google Classroom, we see the first law. क्या बोला? So this Google Classroom is about the first law of thermodynamics. So we have seen that in introduction. It is thermodynamic branch of physics, and that deals with heat and temperature and their relation to the energy, work, radiations. So let's start with the first law of thermodynamics. What is the statement of this thermodynamic? First law of thermodynamics. The original 19th century, statements of the first law of thermodynamics are preceded in conceptual framework, in which the transfer of the energy as heat was taken as a primitive notion, not defined or constructed by the theoretical development of the framework, but rather presupposed as a prior to it and already accepted. The primitive notion of the heat was taken as empirically established, especially through the calorimetry. It is regarded as subject in its own right or the prior to the thermodynamics jointly primitive with this notion of the heat, where the notions of the empirical temperature and the thermal equilibrium. This framework also took as a primitive notion of the transfer of the energy as work. This framework did not presume the concept of the energy in general, but regarded it as a derived or the synthesis from the prior notions, heat and the work. By the one author, this framework was been called thermodynamic approach. The first explicit statement of the first law of thermodynamics by the Rudolf Celsius in 1850 referred to cyclic thermodynamic process. So in all cases in which work is produced by the agency of the heat, the quantity of the heat is consumed which is proportional to the work done. And conversely, by the expenditure of the equal quantity of the work in equal quantity of heat is produced. The Celsius also stated the law in another form, referring to the experience of a function of the state of system, internal energy, and they express it in terms of the differential equation or increments of the thermodynamic process. This equation may be described as follows. In a thermodynamic process involving the closed system, the increment in the internal energy is equal to the difference between the heat accumulated by the system and the work done by it. Because of its definition in terms of the increments, the value of the internal energy of system is not uniquely defined. It is defined only up in an arbitrary additive constant of the integration, which can be adjusted to give the arbitrary reference zero levels. This non-exercise is keeping with abstract mathematical nature of internal energy. Internal energy is constituently restricted relative to the conveniently chosen standard reference to state of system. So this first law of thermodynamic, it is diagrammatically explained that is it is diagrammatically explained, that is the heat transfer or the work by using this diagram you can explain the thermodynamics. Any thermodynamic system in equilibrium state possesses a state variable called as internal energy E between any two equilibrium states. The change in internal energy equal to the difference of the heat transfer into the system and work done by the system. So this is about the first law of thermodynamics. Thank you.